So you were bending wrist pins?
Yeah, the wrist pin itself.
Wow.
There's all kinds of, once you start doing that, you end up with all kinds of trouble.
Hey, welcome everybody back to BarryT's Garage and another episode of Ask Ed. And I've got Ed right here with me. Hi, Ed.
Good afternoon.
And good afternoon. It is afternoon.
It's afternoon.
It's
just had
afternoon.
lunch.
That's right.
Yeah, so
very good.
Everything's good.
I'm glad to have you along. I enjoy talking to you.
Yeah, good.
That's very good. Well, we've got a bunch more engine questions that you all have sent, and I thank you once again for sending the questions. And we may go off topic a little once in a while with a story, and that's good too.
Yeah, we'll try to get them done.
Yeah, try to catch up.
See what's interesting this morning.
All right, so this has come up before, and Richard Finney is asking about a hot setup for Ford Windsor engines, putting an LS1 heads on them, and you have to build a sheet metal manifold to do it. Have you ever done anything like that?
No.
No, that's not your thing.
No, not a thing.
Okay. Here's a question from Brian LaPlante. Basically, he's saying, does Ed agree that an inefficient combustion chamber allows for more advanced timing to burn uncombusted fuel, improving efficiency? So that sounds a little bit difficult for me to follow. Do you follow that?
He wants to change the combustion chamber?
Are you able to run advanced timing because of the inefficiency of the combustion chamber? So you're advancing the timing because it takes longer for the fuel to burn? Is that what's going on?
Sounds like it, yeah.
Okay.
I know sometimes we've always liked 34 degrees, things like this that I know through the dyno things, and maybe 34 runs better, sounds better and runs good, but sometimes 32 will burn a better percentage of the fuel.
Okay.
Yeah, so it's not that. Depends on the fuel, whether it's that, and a lot of times burning combustion fuel, the better percentage of it, especially gas mileage, is the vacuum advance. Yeah, sometimes I always tell people, if you want gas mileage, put the vacuum advance on. If you don't, leave it off.
Okay.
Sometimes the distributors you buy, a Mallory distributor, don't have vacuum advance on it.
Right.
But those are mainly made for racing.
Okay.
And that keeps the timing precision, full range of RPMs.
I see.
Yeah.
Right.
It's got nothing to do with gas mileage.
No. Right.
Yeah, and they're more of a precision distributor. But then the gas mileage was with the vacuum advance on it, and that's the older cars too.
Okay.
Not necessarily the new computers.
Right.
Computer can do everything.
Right. Yeah, it can take a lot of information from around
from everybody. Yeah, the heat and things. And
yeah.
I know one of the guys asked me the other day about what's that thing hanging on the bottom of the Chevrolet, like a drain plug. It's a knock sensor.
Oh, right.
So sometimes, let's say you were sitting someplace in the traffic, and you're just sitting there, and pretty soon the engine gets hot, and the timing will change. And the engine RPMs goes right down at low RPMs.
Yeah.
And pretty soon to lower that timing, richened the carburetors, richened up, and the temperature went down, and the timing went back up, and you haven't touched anything.
Right.
You're still sitting still.
Okay.
So that's important, some of those things. And a computer nowadays, without that knock sensor on the early Chevrolet computers, then the new computers handles all that stuff.
Okay, now I'm just going to back you up one little bit and say,
Sure.
Would you mind explaining what is a knock? What is a knock sensor?
A knock sensor is when the motor makes a noise,
Okay.
like a ping,
Yep.
spark knock.
Yep.
So basically, you could take an engine and start it running, and maybe set the timing up at 1,000 RPMs, and take a hammer and hit the side of the engine or hit the intake manifold, and you keep hitting the intake, and that timing will go right back till the engine quits running.
Okay. You're talking about, so you're
quitting hitting the engine, and the timing goes right back up again.
So you're basically playing a game with the knock sensor.
That's right. Because
Okay.
that thing can hear.
Yeah, it's listening.
Yeah, listening. And
So-
every time the engine knocks, like it's getting hot, and it will start pinging.
Right.
That's pre-ignition.
Right.
It's so hot that it runs like a diesel.
Right.
And that knock, we call it a knock,
Right.
pre-ignition. Well, that sensor hears that and retards the timing.
Yeah, because that's not what happens to your engine if you do a lot of pinging.
It'll burn a hole in the piston and burn it up.
No kidding.
It'll come apart, yeah. Or else quit running.
Right. So
the
that's a
temperature's
bad
getting
thing.
way too hot.
Mhm.
Yeah.
So another way to
we like temperature in the engine. Normally it's about 800 degrees,
Mhm.
and 11 or 1200 will burn a hole in the piston.
Wow. Yeah.
So 800 degrees is normal. Exhaust manifolds turn red hot.
Yep.
Again, we've said that before, that as far as I know, the intake exhaust valve, if you drive at 50 miles an hour, it turns red hot and keeps going. It stays red hot if you drove all the way to New York and back. That's how good a product material the exhaust valve is made out of.
Oh, wow.
Because it's right in hot. Yeah,
It can handle the heat.
it can handle the heat and still seat.
Yes. And that's amazing.
That's amazing. Yeah, yeah.
And one more thing I'm just going to add to what
Okay.
you say. You know a lot more than me, but for people to understand, pre-ignition means the richness and the temperature make the explosion before the spark
Like
plug.
a diesel, before it's fired, before
Yeah.
the spark plug fires.
That's right.
Yes, absolutely. Pre-ignition. Yeah.
Yeah.
Turn the key off, it wouldn't have anything to do with that.
Yeah. Now I remember once having an old car and you turn the key off and it'd still run.
Yeah, yeah. So that's the same thing.
Same thing.
Yeah.
Okay.
Usually that caused by the carburetor's too far open.
Okay.
If the idle is, even then for a while, the manufacturers put a vacuum, an electric switch on the carburetor.
Okay.
It would idle a certain thing with the air conditioner on. You turn the key off, that electric would quit, and that solenoid would jump back and close the carburetor altogether and not pre-ignition.
That's how they
Stop
solved
that
it.
from doing that, yeah.
I never
There's
knew
a
that.
lot of those. A little electric switch on the carburetor.
Well, that's really, hey, we learned a lot just right there. That's awesome. Thank you, Brian, for that question. Phil is asking, he loves our discussion about flatheads. He said, can you use the 8BA, so that's the later flatheads,
Later.
can you use those valve assemblies on the earlier flatheads?
Yeah, we all do that. The early flatheads with the two-piece guide and that stem on the end of the valve stem, I junk them all. Just throw in the trash.
And there's no reason, like the way the engine's put together, you can use those, right?
Absolutely, yeah.
Okay.
Yeah. It fits fine, yeah. And they're used, again, we went over that once before with the reground cam Chevy valves. And we use Chevy exhaust. It was a thing on the thing the other day on my notices that what valves, you can find valves or something.
Right.
And so it's a Chevy valve and you grind about maybe 80 thousandths off the end of it. It's the same length as the other valve.
That's where it lands, huh?
Yeah, yeah.
Cool. We have another one. Albert MK says, I have a question for Steve or Ed. And do the Ford Flathead design heating problems? I think I asked this question about other V8s. Do if it's a Flathead V8, is it automatically going to have the heating problems, even if it's a Cadillac or some of the other old
Not
Flatheads?
necessarily, no.
Okay. What is it about the Ford Flathead?
Well, the Ford Flathead, the two exhausts, the center, because they had the two of them go in one port
Okay.
and go down through the casting right between the pistons
Right.
and come out one port. Just like our dyno test with that one.
Yep.
That one port, the center port, got hotter, much hotter than the two end ones.
Yeah, you can see it on the graph there.
Yeah, right on the graph, yeah.
Yeah.
On the exhaust port, turned blue a little bit.
Yeah.
And the other ones go through the block again and come around right by the water pump.
Okay.
The water pump's trying to cool it. So a guy just called me the other day, which is a good question too. He asked me that he's got a V12 Lincoln. It runs fine. One of the customers here in town. And he had a department putting the water pumps on it. And he watched my video about those deflectors, those 10 deflectors. And he had some of them, but when he bought them to somebody, they were flat. And he didn't know how to bend them.
Oh.
Go right and left. So I told him there's a right hand and a left hand, and it curves back in the engine and deflects that water from the water pump back through the motor more.
Yeah.
It's the same thing now. We've talked about that lately. It's to drill a hole in the back of the block down by the oil pan and put another fitting there and pump cold water into that motor back in the engine.
Oh,
so
I see.
Putting like our Chevrolet race car motors, we put cold water in the motor up front and put it in the back with another hose.
So you're adding
You could do that.
little extra plumbing.
A little extra plumbing, yeah. But
Okay.
the water pump puts cold water in the blown motor. If you could tap a little bit of that off of there,
Yeah.
and some of those water pumps have the fittings on.
Yeah.
And put it
Okay.
back. So there's a little bit of things you can do with a little bit of imagination. And
Yeah. And I guess some of those other engines,
the other
they
ones
let
are,
the exhaust come out in the middle of the engine instead of going through the engine.
that's right, yeah.
So
Yeah.
that was different.
Yeah, a little different for
On
that
some of
question,
them. Okay. Christopher is saying, hey, I enjoy all your good advice. Can you tell me any information or where to find information on Pontiac specific iron head porting? There's information on Chevy and Ford engines everywhere, but he can't find anything on Pontiac.
On Pontiac V8.
Yeah, I'm sure. You done any porting work on those?
Not much, because Pontiac V8, early ones or late ones?
He didn't
say.
He didn't say.
Because I know the center port on a Pontiac shares that one port with the divider. And I know sometimes those two ports are machined back in there a little bit.
Oh, okay.
I seen one the other day, I think on a pair of Pontiac heads here, where the intake ports were right next to one another, and they ported down that intake, took that web out between those two intakes or something. There's a pair of heads over in the shop that somebody was playing with.
Yeah.
But instead of having two ports next door them, there's a thin piece of material in there, and he cut that out.
Interesting.
But I was wondering if he had a manifold cut out too that would match that.
Yeah.
He has to have something in that manifold.
But you're basically just opening it up a little more for breathing.
Yeah, a little bit more volume.
Yeah.
On the intake side.
Now, would you do anything to the rest of the engine?
Well, again, we go back, and sometimes in the 70s, 71, Pontiac had a different motor, 455, that had, the exhaust ports were totally different.
Okay.
And the intake ports were a bit different. And they were big intake ports, but we used to have some of those when their cars were brand new. We played around with it a little bit, and the intake manifold was two-piece. The water neck was one piece. You could take the intake carburetor part of it off without draining the water out of the motor.
Oh, really?
Yeah. But the carburetor part was one piece of the manifold, intake, and the water neck was the other piece. But I haven't seen those motors. I don't even see them ever again after those few years.
Yeah.
So I don't know how many of those they produced.
Yeah. Wow. Say, that's a long time ago.
Yeah, it's a long time ago, but I don't see any of that stuff with the swap meets, and I don't see it on eBay or nothing.
You don't have one hiding back here?
No, I don't have any, but the ports were real big on it.
Really? Okay.
Yeah, big.
Well, I have to ask you, because sometimes you have stuff hiding back here.
Yeah, I don't have any. No.
Okay, good. Does Ed recommend tapping a Pontiac 400 V8 block with a screwdriver handle to free up after assembly? Or what advice do you have for achieving 425 horsepower with ported number 13 heads, reproduction ram air, 3 exhaust manifolds, and a cast iron intake? So this guy's building a big Pontiac 400.
He's asked me a lot of questions.
That's
there.
a lot. What do you think?
See, that was that Pontiac I just talked about.
The same thing.
I think that was a Ram Air 4 or 5 or something.
I think you're right.
And again, we never had much chance. Just to say, we had a few customers that had those motors.
Yeah.
And I thought for a while then that soon after they were in production, some of the pieces had the head cracked.
Oh.
For some reason, I remember that. They took them back to the dealer and they warrantied them.
Okay.
So I don't know. Now, let's repeat some of that question again.
Or free it up after assembly. Is there anything about the assembly getting things too tight, or you don't know?
I don't know.
For
I
sure
never
what
heard
he's
of that.
talking about.
He's tapping the connection rods.
Yeah, we talked about
centering them or something after he assembled. It sounds like he's assembling, because you wouldn't have anything to do with tap. Maybe the rods and pistons are in there, the cranks in the block.
Yeah.
It's to tap them sideways a little bit to center them. We do a little bit of that too, to make sure that the rod slides back and forth a few thousandths on the crankshaft. And that's one of those things where that some of these crankshafts, the minimum clearance on the connection rod back and forth is 8 to 10 thousandths.
Okay.
That's minimum.
Okay.
Now what's maximum? We've talked about that before. I like to cut my rods 25 or 30. They don't say anything about maximum. 25 or 30 side clearance.
Okay.
I think he's doing the 10. We got him in there, tap him with a screwdriver a little bit, so it centers that rod on the wrist pin in the piston,
Okay.
and the wrist pin on the crankshaft. Just to center it so it's not bound in any particular direction.
Okay, so when you're building an engine, this is an engine building question.
Yeah.
So when you're putting that assembly together, and maybe you're vibrating it a little bit, make sure it finds its place.
Right, yeah, make sure it's fine, yeah.
Well, once it's found its place, does it pretty much just stay there
Yeah,
after
it's done.
that?
Yeah.
Okay.
And probably as soon as you started it, rotate it, it's going to find itself anyways.
Yeah, right.
it's not going to sit there and be pinched.
Right.
And sometimes you put the rod in, of course, we all know that. You put it in there, and that's why you tap it a little bit, because the rod on the crankshaft, it could be twisted a little bit sideways.
Right.
Like this, because it has a couple thousandths on the clearance between the rod bearing and the crank.
Right.
Just got to get that, just to put everything the same.
Yeah.
I
Okay.
still like the 25, 30,000 side clearance.
Yeah.
And the oil don't stay in that rod. It goes in the oil pan, cools off, and comes back around cooler. So the more of that side clearance you have on the connecting rods, the cooler the oil in the oil pan will be.
Okay, because it's going to flow easier.
Flow in there
through
instead
that.
of stay in that main bearing, stay in that rod bearing there.
Yeah.
See, if it stays there very long, it gets hot and it will melt the bearing, the lead right out of the bearing.
Wow.
We did that before in our Chevys, but not necessarily Pontiacs.
You're right.
It has to do with all these motors.
Yeah.
I like a little bit more rod clearance.
Okay.
Yeah. Side clearance the rod, yeah.
Now that extra flow of oil, that doesn't drop your oil pressure, does it?
No, it's got nothing to do with oil pressure.
Okay.
Oil pressure between the bearing and the crankshaft.
Okay.
That's your 2,000ths or something like that.
Yeah. Okay.
1.5, 2,000ths. That's
Okay.
your oil pressure.
Our friend, this fine old truck, is asking, does Ed think a 355 engine with an XR264 HR10 cam, broadex heads, boy, we're getting a lot of detailed questions here,
Okay.
9.89 to 1 static compression, 7.38 to 1 dynamic compression, and a 0.044 inch quelch, can you get that to perform reliably?
Well, that's a 10 to 1. He's got put 9 to something. That's what's the reliability of it.
Okay.
Is a 9 to 1. And in that area somewhere, he's got a lot of questions there. That's a lot of specificities. He's doing a lot of homework.
Yeah, for his specific build.
Yeah, for his specific build. And the reliability was fine if he's got to run some little better gasoline.
Yeah.
Or some gas additive, 4+ gas additive or some kind of gas additive maybe to run it perform.
Yeah.
And then the ring gap. The ring gap's the most important then, the gap in the ring.
Okay. How does the high compression affect the ring gap?
Well, it's going to get hotter. The rings are hotter and they spell up, but the worst thing to do is have that ring touch one another. So we'd like to have 20, 25 thousandths ring gap.
Okay.
Top and bottom, depends on who the rings are.
Okay.
With that much compression on the street, sounds like to me.
Yeah.
Reliability is on the street, not necessarily drag racing it.
Right.
So it sounds like that's what he wants to do. He looks like he's going to have a nice motor.
Sounds good. Okay.
The cam, I don't know, I might put a bigger cam in it.
Okay.
He says 268 or something like that. That's a little bit above a stalker.
264.
264, that's not a big cam.
Okay.
With that much, I'd run a 280 cam.
Okay.
280 something, a little more duration, holds the valves open a little bit more.
Okay.
I really would.
Yeah.
260 is an RV cam,
Okay.
like a pull up a hill or something.
Okay. That's a torque your
Yeah.
profile, I guess.
Low RPM.
Low RPM.
Yeah.
Another friend of ours who often makes comments, Daryl Hudson, he would love to find out what your preferred specs are for building reliable engines. Like when you're trying to consider, and he mentions camshafts, rods, pistons, compression ratio, timing, like all the ingredients for a soup. Now, how do you deal with that? Because there's a lot of different ways to do it and different engines.
We have our way of doing it probably, and I have my things that I would do.
Okay.
And once we build an engine like that, just like in the engine shop, 5-star over here,
Yeah.
we'll change something on the engine. If we change something dramatic that we don't know, we'll send it down to the dyno shop and run on the dyno, see how much horsepower it puts out and everything else. And if we change it for something else, we'll send it down to change it.
Right.
And once we come back with those specifications, whatever they might be, we'll keep building that motor on it just like the same thing.
Right.
And we know it's going to put out so much horsepower.
Right.
Yeah, and be reasonable.
Yeah. Yeah. So as far as general specifications,
general specs is,
it's hard to say, isn't it?
it's hard to say, yeah.
Yeah.
And sometimes it just depends on what vehicles, a heavy vehicle or a light vehicle.
Yeah.
All changes everything.
Are you circle track racing? Are you drag
Well,
racing?
it sounds like on the street. Most of these guys, our customers, are
this
not.
is going to be street.
Are not. They're just street cars.
Yeah.
That's what we're going to consider. I hope that's right.
Yeah.
It's a street car, and maybe a little nitrous oxide on it once in a while don't help. I mean, it does help. Excuse me.
It doesn't hurt.
It doesn't hurt. Yeah, I like nitrous oxide.
Do you?
Yeah, I have several units over here.
You've got a few bottles around?
Yeah, I got 3 or 4 bottles over here.
Okay.
I used to sell it quite a bit.
Was that right?
I was probably one of the first ones in Phoenix here to actually mess around with it.
Is that right? You're one of the first nitrous guys?
Probably one time, yeah. The first ones that I remember was made by 10,000 RPM. Was a hot rod shop.
Okay.
They made clutches, like clutches for 4-speed. And they started making this, messing with nitrous oxide.
No kidding.
Yeah.
When would that have been? How long ago?
Quite a few years ago.
Yeah.
And even my nitrous oxide bottle, I've had it in the trunk. And it was some time ago, we ran a heater hose from the motor, a regular heater hose, and wound it around the bottle.
Okay.
And it came back to return it to the motor. So the hotter that motor got, the higher the pressure in the nitrous. Because we heated the bottle up.
Oh, so that...
to cool it, that's the same. To cool it, as soon as you cool something, nitrous oxide, the pressure goes right down.
Okay.
That's why you almost have to freeze the bottle to fill it.
Okay.
If you put it with ice, you can take a 10-pound bottle, and put ice in it, you can get 12, 13 pounds of nitrous in it.
Okay, and then you close the valve and it warms up and the pressure builds.
Yeah, it builds up, yeah. Take a tank, a settling tank, and sometimes you don't have enough, can't get the job done, you heat it with a torch.
No kidding.
Heat the tank with the torch and the pressure go up and you finish your job. You got a little welding to do, a little cutting.
Yeah, just you need a little bit more.
Yeah, a little bit more. So, and then even I think somebody, I don't know who it was kind of foolish and we laughed about that, is they sold you a stainless steel box you put in the trunk and fill it full of ice for your nitrous bottle.
It's like, that's
that didn't last. I think that little box for sale lasted about a week or so, maybe.
Yeah.
It was kind of crazy. They wanted to freeze the bottle and lower I don't know what they were doing, but they didn't know what they were doing.
I think gasoline likes to be cool.
Yes,
right?
Cool gasoline because you end up with so much octane.
Yeah.
And if the octane stays the same, I don't know what the same octane is the same as something.
Yeah.
But anyways, if you can cool it, gasoline and any liquid goes for 10% every 100 degrees.
Yeah. So they probably got it backwards. Gasoline was a good thing to cool, but nitrous was not a good thing.
That's right. Yeah, I don't know who thought that. It was a major manufacturer.
Really?
That made that stainless steel box.
Huh.
And put ice in it. I get it, maybe that sales lasted about 2 weeks.
Didn't last.
Yeah, right. So
that's pretty good.
So it's fun. Funny. Nitrous oxide's fun.
Yeah. Apparently you can have a lot of fun. Yeah, I can see that.
With nitrous oxide, we used to, of course, it's 14:1. Same auto ratio. You have 2 solenoids, one for gas and one for nitrous.
Yeah.
I don't sell it anymore. I just play with my own.
Yeah.
But we would buy a small system. Maybe a 50 system.
Okay.
And if you bought a 150 shot, it was just bigger jets.
Okay.
Yeah. So you find out what the jet was and buy a 50 system, a little cheaper, and just drill the jets out.
Okay.
But you have to drill them out, both gasoline and nitrous both, and you can get whatever you wanted out of it.
Okay. That's how you enjoy experimenting like that.
Yeah, because it's just common sense.
Yeah. Blairson is saying, does Ed confirm that Chevrolet lifters are less durable than Cadillac lifters?
They take more pressure.
They can handle more pressure?
Yeah, Cadillac pressure with the lifter kind of bled off.
Oh.
Yeah, kind of bled off. But they had light valve springs in a Cadillac. Maybe 80-pound valve springs with a blade-off lifter. That's why they idle so smooth.
Okay.
If you want more RPMs of it, put Chevy lifters in it, but made a bigger valve spring. Put a heavier valve spring in it to match the Chevy lifters.
Okay. And then it wouldn't be quite as smooth.
That's right. Well, it pumps the lifter up.
Yeah.
Yeah, more pressure in there. Yeah.
Okay.
So that was the deal. We used to put Chevy lifters in our Cadillacs, depending on what you're doing again. We don't usually talk about what we do at the boring bar on our motors.
Yeah, I think.
But that's okay too. I have no secrets.
I'm remembering something that became a very popular video, and that was when you talked about using a Dodge crank in a Chevy block.
And a Chevy engine, yeah.
And someone pointed out the difference in the bore spacing. It's just a little bit off.
Yeah, right.
And they're saying maybe Ed used some offset boring to make that work.
Yeah, so say we don't know.
We don't know. He's not.
But again, I don't have any secrets. But I can't remember a few things.
Okay. That's fair enough.
But there's all kinds of things, again, if you're building motors like that and doing something like this, you can do what you want to do, and it's fun to do. And carefully like that, you're not going to ruin anything.
Mm-hmm.
So go ahead and do it. Enjoy it.
Yeah.
Yeah, just have fun.
Okay.
Yeah.
Okay, I got pretty close on that one. That was good. I enjoyed that. Florentino, what a great name. What's your opinion of a 1962 Chevy truck rear end? I found it interesting how it had a third member like a 9-inch Ford, and it had an inspection plate on the back. Do you know anything about those old pickup trucks?
They were old Chevy trucks. Yeah.
Do you have any thoughts about them in particular? Or
no.
Didn't really use them?
Or? I don't know if there's any gear ratios. Would never use it in a race car.
Yeah.
They said never do that. No.
Yeah. Okay, that just wasn't
a good idea.
Like a Ford 9-inch.
It's a good idea for Chevy to do that because you can take the cover off the back and look at it, make sure it was wore out or not, or all kinds of things. But inspection covers always, anything that's got inspection cover is always a good idea.
Scott Taylor says, I had a 16-foot jet boat, and I know I already got your attention.
Okay. 16 foot.
16 foot. That's not very long, is it?
It's not very long, no.
But it had a 455 Olds.
Okay. Okay, that's...
It grew up on the lake, and it was a great boat, but the best advice I got was, if you really want to go fast, buy an outboard. But nothing sounds like a big block. And he's asking, did you ever mess with Jersey Speed skiffs? And I guess that's a boat maker.
No.
They usually ran a 283 Chevy. So have you had a jet boat like that?
Yeah, of course we did. We've had jet boats forever. 455 was always a good motor for boats.
Okay.
But they was usually 18-footers.
Okay.
18s, and then day cruisers was 21.
Yeah, so this 16, that's pretty...
That's a pretty sharp boat, yeah.
Yeah, you better...
I don't know what he's talking about there, but it was a jet drive. And we had some jet drive, some of our boats, I think Eliminator was our first one, made out of California, and I was actually the distributor for him here.
Okay.
For a short while. We sold several of those boats, and it wasn't a flat bottom, it was a V bottom, but half V and half flat.
Oh.
So it kind of made it halfway between. That was Eliminator.
Huh.
Then sometimes we put speed grates on it. A speed grate was, instead of having the bottom just flat, you could run over anything. We put some angle irons, maybe a short angle iron, and put it up in there, and two angle irons that stuck in the water.
Okay.
So that scooped the water. Instead of being a flat bottom, these things stuck down on the bottom of the boat. That scooped the water in the jet.
Oh, I see.
Yeah.
Okay.
If you got them going real fast, then you had to have the flaps on the back of the boat that set down and keep the front end out of the water, because the boat would go higher. That short boat's going to get higher and higher in the front instead of being up and plane. And you had the flaps in the back, and they were sometimes on a shaft, and then two flaps, and you could push those down and push in the back of the boat and keep the front down. And if it was a real fast boat, that would be that 455 with a couple carburetors on it. It's all kinds of things. You got fun with a jet boat.
That'd be a lot of fun, wouldn't it?
Yeah. And sometimes the exhaust, we used to do the exhaust on that with the water manifolds, the exhaust manifolds.
Yeah.
It was about 4 inches. Then they round the manifold in that boat, they kicked it down to 3-inch. So the 3-inch exhaust out through the back of the boat.
Okay.
So we sawed that off and put a 4-inch pipe on it, because the manifold was made for that.
Yeah.
And changed our bigger flips up. It was a 4-inch exhaust with 2 4-barrels on it.
That did some breathing.
And that would give a little bit more breathing on the exhaust side, yeah.
Yeah, wow.
So there's all kinds of things. You can have a lot of fun with a boat.
Yeah, okay.
Yeah.
Ford always used to have a crap starter that slammed into the ring gear and chewed it up, and then would kick out the first time the engine fired. That's his opinion. He said, do you agree that that was a bad idea or an inferior design to the GM's solenoid type starter?
Not necessarily a flathead starter. He
didn't
say that.
He's just throwing the whole Ford company under the bus right there.
Yeah, well, I guess threw them all under the bus. But the Ford flathead starter,
yeah,
we still run that 6-volt starter or 12-volt.
Yeah.
We take them apart and clean them, armature.
The brushes too.
Brushes and clean them all up. Yeah. We were good, and grease them. Greasing the shafts and oil them up good.
Yeah.
And that's what it starts on our flathead motors with 12-volt.
They work fine.
And they work fine. It lasts a long time, because if the motor starts, it don't need to crank very much. You see our flatheads, a couple of turns, they're fire and run.
Oh, yeah. Yeah.
And the Ford starter, then, that 302 starter, has a separate, it was kind of weird because they have that steel plate behind the motor.
Yeah.
And that centered the starter.
Okay.
Without the steel plate, it would bolt on the bells, and then you were in trouble.
Okay.
But that was kind of a weird way to say it. And you end up getting into General Motors then with the solenoid starter, and that's misaligned then.
Okay.
You have to shim it all the time and do
that's
some
right.
weird things about that, and people don't understand how to shim a starter. And
What about
the starter hangs below the center of the whole motor.
Yeah.
Starter hanging, but the more you shim it down, the worse it gets.
Right.
Yeah.
As long as we're talking about starters, what about the Chrysler starter with the gear reduction?
Chrysler starter was a good starter.
Yeah.
There's one on this motor right here.
No kidding.
Yeah, it's a late model Chrysler starter.
Yeah. Some people hated the sound of it, but it worked well.
Yeah, it worked well. Yeah. And they started good. It was a good starter. Yeah.
Okay.
They were kind of difficult to fix.
Oh, is that right?
Yeah, they was difficult to tear apart and put back together again.
Okay.
And the first ones, I went to school in 1959 about that starter, so I know a little bit about it.
You might know.
Yeah, I know a little bit about it when they first came out.
But that was the first. Yeah, that's the first year they came out, wasn't it?
Yeah. 60 cars had them.
60 cars. Yeah.
Hope he answered his questions. I don't know, but
Well, yeah. Well, he wanted your opinion, and you gave your opinion.
that's my opinion. Yeah.
So that's very good. Have you ever used Gliptol paint to paint inside your engine as opposed to something else?
We use Rust-Oleum.
You just use Rust-Oleum.
Yeah.
Jay Brooks has a question. Do you have to strengthen the piston around the wrist pin when you do a big bore short stroke? Wouldn't it take a big hit from that extra?
The area in the piston.
Yeah, the
Depends on the
piston is
manufacturer of the
pushing.
piston.
Okay.
You have to be careful with some of those cast pistons. If you broke one all, the whole thing shattered. With the manufacturer of the piston, you start doing that, you gotta buy good pistons.
Okay.
That whole thing goes in there. You don't put a stroker together, stroker motor, and expect to get horsepower off a cast piston.
Yeah.
Yeah, you'll have trouble.
You make sure all the ingredients are right.
Yeah,
not just
right.
a
Yeah.
few.
Yeah.
Okay.
They crack the skirts first down the side when the piston turns sideways.
Okay.
They crack the skirts
He'll smash it into the.
before it rips it. Yeah.
Okay.
The only thing we had was some of the big block Chevys. We used to, when we were putting some power on, we bend the push rod.
Okay.
Actually bend it.
Wow.
And so we turn around and put Chrysler wrist pins in it then.
So you were bending wrist pins?
Yeah, the wrist pin itself.
Wow.
Yeah.
Wow.
There's all kinds of, once you start doing that, you end up with all kinds of trouble.
That's right. Too much nitrous, you got a lot of problems.
Yeah, too much, yeah.
Okay. Daniel's asking about the 377 builds. Do you suggest any specific changes to the main bearings when you're building a 377?
Not really. You want to put a 4-bolt main.
4-bolt mains.
Yeah, 4-bolt main or a splayed bearing, splayed mains.
Okay.
Of angles.
Uh-huh.
Yeah. You want to do that. Make a good main bearing because it's getting a lot of RPMs on. You get a lot of harmonics and vibrations and that many RPMs because that's what you're building, a 377 motor for RPMs.
Yeah.
Some of the questions was, the Chevrolet, did they make a 302 motor and then it was banded because, or disqualified or something like this. So they did make a 302 motor and it was high one. It was a strange motor.
Was that the DZ?
Yeah, DZ motor.
Yeah.
Yeah. It was different to drive a car with a DZ motor.
That's a high RPM car, right?
Yeah, right.
Does Ed agree that fitting a 350 crank to a 400 block requires suboptimal special bearings because the 400's long stroke is a liability compared to a Ford 400 for high RPM?
Well, you have to put the bearings, unless you buy a crank.
Okay.
It's got a crank made for it, but you have to buy those other bearings over here, like 2 sets of main bearings.
Mm-hmm.
It's a shim bearing. It looks like a bearing itself, okay? And you put one bearing in the other one
Okay.
to get that crank to fit in there, yeah.
Okay. Is there any problem with the long stroke?
Not really.
Okay.
Yeah. It's not that much longer.
No big issues on that.
No big issues now.
Okay. Now Jesse is asking, does Ed see any advantage to leaving combustion chambers as cast rather than smoothing them, such as improved combustion or atomization?
I understand what you mean by that. Smoothing would be pouring and polishing the combustion chambers.
Yes.
I think, I don't know if I spend more times on the runners
Okay.
behind the exhaust valve and that stuff, trying to get it to flow more.
Okay.
And the intake ports should be smoothed out. Exhaust ports should be too, but not so much in the combustion area.
Okay.
So that's my opinion.
Yeah.
Combustion area, sometimes you have to be careful there. And I don't know that much about it. I don't have a machine that would test that. Once your combustion explosion, how to get the gas on that chamber to go out the exhaust pipe, out through the valve fast.
Right.
They'd be in there polishing the valves and making the valves thinner and the 3 or 4 angle valve jobs and
Right.
things like this. All has to do with it, more than just polishing the combustion chamber, if that's what he wants to know.
Yeah.
Maybe polishing the top of the piston and buying a piston that's with the deflectors on it makes it go where it's supposed to go.
Okay.
Yeah.
All right. And I will just quickly say there's a lot of controversy about
Everything.
everything.
Yeah. The guy you need to talk to, but he won't talk to you,
Yeah.
is probably the NASCAR engine builder.
Yeah. They won't tell me anything.
Yeah, they won't even say hello.
No, they're such grumpy guys.
Yeah, I think the engine builders aren't even married.
Okay.
Probably not. They don't talk to anybody.
Yeah, so if anybody can find a NASCAR engine builder, please.
Yeah. Tell me. I want to see one.
We have some questions for him.
Yeah, we like to talk to him. Yeah.
Okay. Now Jimmy is asking, do you ever use solid lifters on a hydraulic roller cam? So you're mixing two things there.
He's talking. He's got to be talking because you can't run solid lifters on a roller cam. That
Okay.
would last about 2 seconds.
You just chew it up.
Yeah, chew it up right there. I'm sure he's talking about solid roller lifters on a hydraulic roller cam.
Okay.
No, I have not done that.
You've not done it.
I don't know. It'd be interesting
Okay.
to build one. I would probably want to build on an engine stand
Mm-hmm.
and make sure it depends on what you want to adjust the valves at, because you have the ramps and stuff that takes care of the hydraulic lifter.
Yeah.
Like we used to put solid lifters on a hydraulic cam. The ramp wasn't there, so we had to adjust the valves at 2 or 3 thousandths. And solid lifters on a solid lifter cam, you adjust the valve at 25 or 30.
Okay, that's a big difference.
Big difference, yeah. And it says that, anybody knows that. But like in the old cars, like a 55 Chevy, and you had hydraulic things, you put solid lifters on it, then you adjust the valve at 2 or 3 thousandths, and it would wind another 500 RPMs.
Wow.
Yeah.
Okay. All right. So Steve is asking, can Ed share his techniques? You remember you did the video, a lot of people watched it, of fixing the oiling on a small block Chevy. It's a very popular video. And people would love to see you do that for Ford and Mopar engine builds. There's so much detail, and every engine design is different.
Yeah.
So you can't do it.
Yeah.
We'll do what we can. We'll make videos.
And I don't really, I'm as old as I don't build motors very often.
Right.
I do some flatheads, that's the truth now.
Yeah.
I do not build a race car motor today.
Right.
I don't have a race car. We sold it sometime, our last race car.
Yep.
And we sold it a couple months ago.
Yes.
And so I will not build another race car motor. I don't. And in the shop, we build motors over there all the time, and they have some special things they do. I'm not sure that they do very much, as much as we did with the Chevy motors when we were racing them.
Yeah. I think the best advice we can give you is check out the engine oiling video and think about the principles that Ed is using to figure out how to modify things. And then,
sometimes maybe the oil pump, between the oil pump and the block, make sure the oil's lined up, the hole's lined up.
Yeah.
One be off center or something like that. That'd be important.
That's a good example.
I did find something maybe 15 years ago. I built a Ford motor. I think I went over that once before. It was a Ford Motorsports motor.
Oh, yeah.
And I just was amazed that the guy was in a modified car, and that was a complete motor you buy a long block from Ford.
Uh-huh.
It was some kind of weird 366 cubic inches or something.
Okay.
It's really a fast motor. But I took the part, and the main bearing holes didn't line up with the main bearing.
Christopher's asking, he heard guys are using Olds 403, I guess that's the block, with a Dodge 360 rods that are supposedly 1/8 of an inch longer, and they compensate by shaving the piston 1/8 of an inch into a flat top. Have you heard of anybody doing that?
No.
Okay.
No. I know the piston's not he's on a 360 rod.
Yep.
in a 340 motor or 318 motor.
Yeah, perhaps. He doesn't say. He just starts with the Olds 403.
403.
Oldsmobile.
What?
Yeah, an Oldsmobile 403. Isn't that from the early 80s?
403 Oldsmobile. That's fine, yeah.
Yeah.
And what rod is he trying to?
He's using Dodge rods that are an 1/8 inch longer.
Never heard of that.
Okay.
Well, I don't know.
You don't know, yeah.
That's,
haven't done that one.
no, I never did that one. That's kind of strange.
Yeah. Well, apparently gives him
that's,
an 1/8 longer rod.
I don't know where he's at with a crank size.
Right. He didn't say.
I have no idea. It'd be interesting.
It is interesting.
You know, it's just, that would keep me up all night. Yeah.
I love it.
So,
Okay.
because with our 350 Chevys, we put some Buick rods in it.
Okay.
Yeah, so that we could grind the crank down and put some, I think, 235 Buick rods in it.
Okay.
That made a stroker motor. That's been years ago before we could buy motors. Not that one. No.
Well, here's one I think, again, we're asking for Ed's opinion. So sometimes just opinion.
Yeah.
So Darwin is saying he is claiming the 460. We've said some nice things about the Ford 460.
Yeah.
He said it's a junk engine, that it needs new pistons on all the factory engines because the piston skirts break. Have you heard of that? I haven't.
No.
Okay.
We do a lot of 460s.
Okay.
And I don't recollect ever having a problem with the 460. The skirt's breaking.
Yeah.
It sounds like he's doing something with that 460. I don't know what he's doing.
Yeah.
Because as many of the 460 motors as they've had through the T-Birds and the whole Ford family had 460s in them, and I never recalled of any kind of a piston problem.
All those truck engines, they must have made a ton.
They must have made 10 million of them.
Yeah. Yeah.
And then whatever they ran them in, I don't know what he's doing with that thing for pre-ignition, it sounds like to me. That wobbles the piston back and forth.
Yeah.
In the skirt, that's what breaks the piston.
Yeah. So
Not necessarily going up and down, but it's doing this to the piston.
So yeah.
Sounds like some pre-ignition.
Does cubic inches always dictate the horsepower and torque an engine makes?
Not necessarily. It does a little bit of stock form.
Yeah.
In stock form it does, yeah.
All things else being equal.
Yeah.
Okay.
Stock form. The bigger the cubic inch has more torque and more, not necessarily horsepower, but more torque, has more muscle.
Yeah. Okay.
Goes right up the hill, pulls like diesel motors. It got 600 cubic inches.
Right.
Yeah, so what was this question?
So the question is the smaller 377 always going to be less powerful, less horsepower and torque than the 400? A Chevy 400 engine.
He's talking about dirt track again, 377 and dirt track.
Yeah.
And a 400 motor.
Yeah, he didn't say anything about dirt track, but,
yeah, but he said
usually that's what that is.
It's a race, that's what he's doing.
Yeah. Is it your opinion that it's always going to be less powerful than a 400? I know you said even a 383 is not as good, depending on the track, than a 377.
It depends on what track you're using. What he's talking about, horsepower.
Yeah, that's true.
I think I would sooner have the 377 than I would a 400.
Okay.
I really would. If I was going to build a motor right now for a particular race car.
Okay.
Yeah.
Is it always going to have less power, though?
I think a 377 had more power.
Okay.
Than a 400.
All right.
Yeah.
So when he uses the keyword always, and he made it all caps, the answer is no, it's not always.
Not always, no, not at all.
Okay.
Yeah.
All right.
Not at all. We have the 377 motors that put out a lot of horsepower.
Yeah.
Yeah, they really do.
Okay, Jessica asks, what do you say about a 426 Windsor? Wow.
426 Windsor, that's a 351 Windsor.
Yeah.
With a stroker kit in it. Stroker crank.
She says it came out in the Short Track magazine maybe in 1984. I guess someone built one of those back in 84.
Yeah.
So you have any thoughts about a 351 Windsor and making it?
We built some 351 Windsor with stroker kits.
Okay.
Stroker cranks in them, yeah. And they sound like a big block, 428.
No kidding.
The exhaust is totally different on them. Of course, you got more cubic inches and stuff.
Yeah.
You want to put a good set of aluminum heads on it.
Okay.
And a good intake.
All right.
And maybe you probably get more out of it. You put a couple carburetors on it. I like carburetors, and put a big intake, a taller intake on it with bigger ports. All that matches the aluminum heads, aluminum intake.
Yeah.
And then with a taller intake manifold,
Okay.
and maybe a good 800 Holly carburetor on it.
Okay.
Put a lot of horsepower.
Now, you've mentioned before the weakness of the webbing in the 351.
351 Windsor is different than 302.
Oh, is it? Okay.
Yeah, main bearings are bigger.
Okay.
It's a lot bigger. 351 Windsor, I love that motor.
Okay.
Yeah.
Good distinction.
That's a good motor. I never had
anything bad to say about it.
anything to say about a 351 Windsor Ford. Yeah.
Okay.
Really, I like that motor. Yeah.
That explains something I know about your truck in the back.
Yeah.
Can you confirm the story that Torqueflight transmission was offered to GM before Chrysler refined it? Do you know anything about the development of the Torqueflight transmission?
I don't know who the guy was that ever designed a Torqueflight. They had a 3-speed transmission with a cast iron case and stuff in it. Wow. And that was the first Chrysler made a 2-speed. Then they made that 3-speed with a push button.
Right.
59. And the aluminum transmission came out again in 1960, but I really never, even all the stuff I've known, I don't know who, some particular guy or some engineering company had offered a Torqueflight.
Yeah.
But basically it's almost identical to the Ford transmission and the General Motors Turbo 400s, Turbo 350s.
Okay.
All those transmissions are almost identical transmissions.
Interesting.
There's a little bit of difference on the planetary system where one takes more horsepower to turn than the other one. So,
we know a little bit that in Detroit, there would be an inventing company or somebody developing something, and they would shop an idea to all 3 major companies in
possibly,
Detroit.
but that would be, I don't know if that happened.
Yeah. Our friend named Larry says, do you agree that it's a shorter stroke increases torque while a longer one favors horsepower?
Longer stroke is more torque.
More torque.
More muscle.
Yeah.
Yeah, but not necessarily more
So this is kind of backwards.
Horsepower and torque.
A shorter stroke engine lets you rev higher. And
Rev higher quicker.
And horsepower is speed of torque,
Yes.
right?
Yeah.
So it's actually, Larry, you have it just exactly reversed. It's actually the short stroke gives you the horsepower. The long stroke gives you the torque.
Yeah.
Yeah.
Like
Just think of a crowbar. The longer the crowbar, the more you can lift.
yeah, more muscle.
Yeah.
The other one's going to go faster, but won't have as much muscle.
Right.
Yeah, that's right. Yeah.
Ed, thank you so much for answering
Okay,
all these
good.
questions.
Good.
This is a lot to
A lot
go through.
Yeah, a lot of information there. We get it
Yeah.
all correct. Yeah.
And as much as that was a lot of questions, we have a lot more I've got to assemble.
Okay.
We're not keeping up, but we're going to try. We're trying to keep up, and I appreciate you, Ed, taking the time.
Good. We should do some videos about something more mechanical.
Yeah.
Something, tearing something apart or find something. I think we have some of that.
I think, yeah. And I want to follow that 38 Flathead you're working on.
Yeah, the one I dug all the studs out of the.
Yeah, did you
all
get
the
them all
bigger
out?
head studs.
Yeah.
Yeah, I haven't made him a bill yet on that. I haven't got the nerve to add it up how many hours I got on it.
It was a long time, I'm sure.
Yeah.
Okay, well, thank you for joining us. Thank you for the comments, and thank you,
Good.
Ed.
Yeah, enjoy.
And see you next time on BarryT's Garage.
Very good. Thanks. Thanks for watching.
Thanks for being a part of BarryT's Garage. And if you want some Ed Smith memorabilia, some hats and shirts and all, it's just edsmithspeed.shop. Head over there and have a look.